This conference will now be recorded.
All right, everyone, welcome. So the first topic will be on SSD form factors. So over the past couple of weeks, we've had, in-person meetings. We've had some thermal data that we sent out from Microsoft, and a few of us have gotten together and have a new common proposal that we'd like to share today. So Bill or Paul, did you want to do the presentation, or do you want me to pull it up? How do you guys want to do that?
Bill, if you could do that, I'm in the car right now. That'd be good.
Bill, you able to hear us?
Yes.
All right, I don't know if Bill has audio yet. He's on.
Stay in the middle too late.
So Jason, if you have the slides, why don't you kick it off? Maybe Bill is late. That might something.
All right, yeah, she was on here. Let me go ahead and share. So I grab this. Hold on. Give me just a second. Let's see if I can go to presentation mode if this shows up. All right, is that coming through for everybody?
Yep, I can see it.
All right, do you see the full screen mode or do you see presentation mode?
Yeah, presentation, the preview, the presenter's view.
Oh.
That's good.
How about now? Better?
Yeah, that looks good.
All right, cool. All right, I'll kick it off, and as soon as Bill lands on, I'll pass the torch over to him, or Paul can jump in at any time. Since you're so
Your audio is poor. We can't hear you.
you can't hear us?
No. It's very, very flaky.
Anybody else having problems hearing me?
Yes,
yeah, it's pretty bad.
Yeah. Your audio's pretty bad.
Yeah, it's very bad.
How about now? Any better?
Still bad.
Go bad.
Any better? Is this any better?
No.
Not any better. All right. I can hear you guys just fine. All right, as Bill or Paul, you guys want to do the talking? I can flip through the slides.
You may want to rejoin.
Yeah, here I got my screen switched in audio. It's just fine.
I'll project on the screen so you can see.
So who's talking to this? Is it Jason?
Looks like I got off the call by mistake.
Hey, is Bill? Are you online yet? Or Tony, is Bill online? Can you tell?
No, I can see Bill online yet.
Hey, this is John with HP. All right, is this any better? Can you guys hear me now?
That's
Yes,
much
very
better.
much better.
There we go.
100%
All right.
better.
All right. Sorry for all that. All right. Let's get going then. So we've had all these conversations on how we start to find common ground. And Microsoft, Dell EMC, and HPE, we all came together and said, all right, how close can we get? And we have a common presentation we'd like to share and be able to distribute this to the group afterwards. I think we're certainly making progress on trying to find this common ground that reduces the overall amount of form factors that we have. So we have a couple slides we'll walk through in the high level, and then there are some details that the Dell EMC team can share, similar to how the Microsoft team shared our methodology and how we came up with our requirements and our airflow needs. The Dell EMC team also has that. All right, Bill, do we have you on now? Guessing that's a no.
Yeah, I'm wondering if Bill knows what time this meeting is at. I'm gonna try to reach him on Skype, and I'll let you know if I can get a hold of him.
Okay, so he's on the bridge, but I don't know if he's having audio issues. Maybe he has a similar to mine.
Oh, okay, yeah.
All right, well, I'll continue in the meantime until we get Bill. So I'll present on behalf of him. So at the moment, we found that the drive form factors of today, we're not going to necessarily get down to one, because you need volume to be able to get capacity, and you also need a certain amount of volume to be able to have enough airflow and thermal capabilities when it comes into performance. And so what Bill proposed here is that, if you want a traditional style form factor, 3.5-inch hard drives, a lot of volume and a lot of space. That's why hard drives use it. In the past, we've seen SSDs use that as well. That is a lot of volume. Then we go down to performance, where you saw SFF come out with drives, with 2.5-inch drives. It gives you a blend of volume and then capacity and performance. And then we've seen in the last couple of years the M.2 take over, where we have very small capacities, but we can fit a lot of them in there. This is great for things like boot drives, but not so good for maybe high performance devices, specifically because it is not cased and it requires thermal solutions, thermal interface materials, heat sinks. So it really wasn't designed for high performance applications. With that in mind, we can go to the next slide. There we go. So one of the things we want to make sure is when we come up with a new form factor, we don't want it to be a one-time application, and then in a few years we'll look back and say this didn't have the performance capabilities, the thermal capabilities. So when we're seeing new protocols emerge, in addition to your traditional PCI and NVMe, we now have CXL and Gen Z. Sorry about that. So we want to think about what does that mean over time, and you'll see other form factors that have come to think about these things as well. For example, the OCP NIC, and they're all leveraging the SFF 1002 connector. So we think that actually makes a lot of sense, and you'll see in this proposal, all of the things we're looking at are following these guidelines. And again, one size does not fit all, so you certainly expect there will be a family of devices. And so this is showing some of them. So in the past, some of the documents that I had shared were mostly focused on E1 and E3. This includes the different variants of E3 as well. So there is the long and the short, thick and thin. And then this shows some of the E1 variants, which are the E1 thick and E1 thin. What's not shown as the long. And so we'll certainly update that and start pulling some of our presentations together. But we'll see there are some trade-offs as far as how much volume you have and then the power limits. And we don't have to pay too much attention to the power limits here. We have a table coming up in a few slides to actually talk about that.
Hey, can you hear me now?
Oh, we can hear you, Bill. There we go.
Oh, all right. Finally.
Do you want to continue presenting your slides, and then we can chime in at the table as a team?
Yeah, so basically what we are looking at is trying to come up with a interoperable family of devices that will sort of hit all of these different use cases. We realize we need use cases that are optimized for one use cases that are optimized for two use. We also need use cases that are optimized for capacity, use cases that are optimized for performance. So essentially what we're looking at is having these variants all interoperate within the family so that you can take a 1U device and stick it into a 2U slot and it'll still work. You can take a 2U short device and stick it into a 2U long slot and it'll still work. So essentially that's what we're trying to do. This has a lot of different benefits, and mainly for the device vendors not having to replicate capacity points in multiple form factors. You can, have one capacity point in one form factor, and we can use it in the other slots. Especially the 1U short, we can use in the 2U devices. So essentially, we have the narrow devices. I tried to stay away from thick and thin because everybody gets confused. I'm using narrow and wide. The narrow devices are lower power devices, primarily aimed at NAND. The one exception to this rule is we do see a use case for a wide 1U device for NAND, specifically so that we can hit the 25 watt power envelope needed to saturate a PCIe Gen 4x4. So, any questions on this? You want to go to the next one?
All right.
So something 16.8 instead of a 15 millimeter now?
Hold that thought for a second. So we're going to get to the chart. So the 16.8 is kind of the legacy pulled in from the E3 specs. And you know that we provided a proposal of 15. So we'll highlight that we're not fully aligned on the thickness, but everything else is. So we'll focus on the commonality right now. And then when we get to the chart, let's dig into that 15 versus 16.8.
Sounds good.
So hey, Bill. Hey, I have a question from the previous slide. So the short is now 38.4.
So that's going to be a proposal, yes. So what we would like to propose is that we actually have the E1 short match what the E1L was. Because E1L is out in the wild, E1S is getting very close. There's no reason to have them as two separate heights. Because if you look at this matrix right here, if you put in the E1L versus E1S, you'll see they're different, and that starts making a very complicated story for commonality.
And the key thing to think of there is that that's the cased version of the E1S would match the same height as the cased version of the E1L. So we're not saying that we're going to grow, like the 5.9 PCB only version to be the same height. Just think of it case to case version is the proposal.
Yeah. Yes.
Okay. So
We'll look at a table that'll summarize this in just a bit too.
Yeah, I think we'll need to circle back with that. I mean, there's a lot of reasons we chose E1.S height to be shorter than this. So let's talk about that when we can circle back. But you go ahead.
Okay. So a very important part of this is essentially having the connector have the same registration point across all the different variations. Now this says, essentially when you plug in a short by 4 device, it could work in a 1U by 4 device. It can work in a 2U by 4 or by 8 or even by 16 if you wanted to for some reason. So the connector or the family of devices will support by 4s, by 8s, or by 16s. And essentially you could go down to by 2s also or 1s, but the minimum connector width is by 4. So as part of this, that means all of these devices need to be asymmetric. So when you look at the wider devices, you need the connector essentially in the same place as a narrow device. So that forces an asymmetric design. Any questions on that?
Is that okay for mechanical stability and stuff like that?
We believe so. I mean, these aren't huge devices.
No.
Hey, this is Glenn from Intel. One thing I would mention, though, the spec does not call out mass in these things. And so as we look at different types of devices, maybe even accelerators in some of these form factors, having the enclosures made out of copper or other things like that could increase that weight and that mass.
Okay. So the question there would become, that would probably be up to the system vendor to design a slot and rail system that can handle the increased mass of the device.
Yeah, I would agree that's a system design constraint.
Yep.
Well, but it's also a connector constraint, right? If all that load's going into the connector, that could
well,
be
ideally, you don't have the load. You don't have the connector supporting any of the load.
Well, not necessarily, because many times we do that because we don't want fretting on the card edge fingers, right?
Well, the idea is that the offset from the bottom of the device to the connector is common.
Yes.
And yeah, that would offer you support for the weight at the bottom of the card cage.
Yeah, I
Yeah,
think
you
what he's
don't
saying
want.
though is that this may influence the connector. So let's say you have an SMT connector. If you actually wanted the connector to hold weight, and I'm not saying that's a good idea, but it's certainly been done, you could have a cage with SMT wings to give structural stability or through hole, but I think that's separate from the device. I
Yeah.
think that's more of a connector design. I don't think
Agreed. Yeah.
the goal here has to include, but it's actually an excellent point though. So as these masses do go up, we might need to consider that for future connectors.
Yeah. Agreed. Okay. Any other questions on this one?
I think one other challenge the asymmetric poses is that you can't put a lot of like hot components on the right-hand side of what you're showing in this diagram here, that there's not a lot of thickness, at least with the 7.5 on that side, to put any cooling features.
Well, you can thermally bond components to the backside, and if you provide enough heat relief, you can kind of suck that heat over to the other side of the case.
But that's right. There's no expectation of there being fins on that side, if that's kind of your point. Yeah.
Yeah. Okay.
One question. So in case of the E1.S, the thick device is basically a heatsink, not an enclosure.
Our current use cases indicate that. I don't want to preclude that going forward, but yeah, right now it's mainly for heatsink. There's nothing to say that if you have a low power device that needs some more real estate, you could, there's nothing preventing you from putting 2 PCBs in that area, as long as you can cool it.
I think that's also up to the system designer to make sure they have the appropriate airflow and impedance.
Yep.
But I don't think that's a specification on the device itself. So I think Bill's showing us a very large block versus showing like a heatsink. So when we were presenting our data, showing how we swept from like a 9.5 to the 25 millimeters for the E1Ss, we were extending just the heatsink. So we were assuming a heatsink design.
Is there a reason to leave it open to interpretation?
Yeah, because not everybody will use it for heatsink.
Yeah, I think it's a lot more flexible from a form factor perspective, right? You can use it for a lot of different devices based on your system implementation. So it's, you can either make that heatsink material or you can make that a case for volumetric use. It makes the form factor much more flexible and usable across different use cases.
I mean, if you
Is it going to be a defined block though, such that there is no airflow passing through, or is it going to be?
No, just like we did, there'll be pass through airflow. I mean, just like we did before, where we defined there's guaranteed surfaces and there's there's a lot of devil in the details, right? It won't be defined as here's a rectangular block that you must hit all these dimensions. So yeah, certainly there's a lot more detail we got to parse out.
That makes sense.
Yeah, currently it's kept as a keep in, right? Like it's a keep in enclosure area, which then you can fill however you like, including fins, which obviously there's empty space as well. Right?
Exactly. Yep.
Exactly.
In the E1.S industry standard, we have the card defined, and so then you can add this additional enclosure that the card is still can be the same inside, but then you have the enclosure added to it. So that helps that you can, that may be something else that you want to consider for the others is defining a card. So then there can be one industry standard card size so that you know what you're getting, unless you have some additional construction you want to add to it, but you always can have that one as a thin one.
But if you define a card size and you try to translate it from, U.2 to one E1.S, that may not be beneficial for the power capabilities or density of that platform.
Yeah, I'm saying for like an E3 here that you have in the E1.S, then those could both have a card defined. I mean, it's already defined for the E1.S. It's really a question for the E3 if it makes sense. You can have a card defined.
Well,
I'm not sure.
I think it needs to be platform specific, right? Because you're going to have power requirements for each different form factor.
No, I think what he's getting at is, I think I understand what Jonathan's getting at. Let me see if I can translate this a little bit. So when we look at E1S, there are actually two different form factors proposed, right? So there's a bare card and you have the card with a case. But as we mentioned earlier, if we try to make E1S match E1L now, as that case gets wider, if you were to define that as a wider PCB that would take up the whole thing, then it would no longer fit your use case. You said you're much more constrained. So you can use the uncased with a small PCB, but by not defining that, it allows someone to use a small PCB in a larger enclosure or build a dedicated large PCB to go in that wider enclosure.
We've had carriers we've done some design work on, hey, there's like E1.L kind of carrier that puts the smaller E1.S card in there, and that allows for it to slide into the slot. So it actually helps to have the extra space on the top and bottom so it can slide into the same slot as the E1.L. Mechanical foundation.
And the other thing is, we really don't see a use case for an uncased E3. I mean, the bare card E1 use case makes a lot of sense. I'm not sure a bare board E3 does, unless somebody else can come up with a really good use case for it.
Yeah, so just at least more than half of the concept behind the card definition with the E1.S is not just to have the bare card itself. I mean, obviously you can put minimalistic mechanicals around it, like rails and no full case.
No.
But the main point is really that the SSD suppliers can make one card. For a lot of different variations, they can make one card and have different mechanicals. So, for example, you could have an E3 that's the thin one. The narrow one, the narrow E3, and have that card. And it can be the same card because it's a common card definition. They can put a larger heatsink on it and support maybe higher power. It's a common card that can be leveraged for supply chain purposes and logistics. And so they only have to just one SSD.
Yep, we totally agree with that. In fact, we very much see taking an E1 PCB and putting it into an E3 case. Any other questions?
So I guess if you go vice versa, E3 to E1S, you're just eating into your case, right? Your case
You can only go
performance.
from 1 to 3. You can't go from 3 to 1,
Okay.
depending
Yeah.
on the, yeah.
Yeah, you go from smaller to larger.
So, okay. So I guess my question is, were you trying to set the constraints for E3, or are you trying to change the constraints for E1? The
It's a
Hinkle
little bit of
guide,
both.
sorry.
Yeah,
We're
it's a little
changing
bit of
both.
both. We're trying to get them both more aligned, and so that requires a little bit of changes, we think, on both potentially.
Yep.
Yeah. Are you guys actually, are you going to be planning to use E1.S after this? I mean, because there's others of us have been working on E1.S and looking at using it for a while, but obviously this is a new proposal here. Is this something that you're planning on using?
Yes.
Yeah, I mean, clearly Microsoft is part of this proposal, right? So they're one of the big users of it. So yeah.
I'm talking about Dell.
Dell's looking at using an E1.
We have plans to use E1 as well.
Yeah.
Yeah. Can you fit the 38.4 in your systems?
Yes.
Okay.
All right, should we go through LEDs, and then we'll get to the table, which I think will spark a lot of this debate.
Oh, yeah. I'm sure it will. Okay,
Let's cover LEDs then.
Next slide. Essentially what we want to do is come up with some sort of common LED proposal. Now, this is one item that is in the issues list, so we need to talk about this. But right now, we've got LEDs kind of scrambled all over the place, depending on what form factor you're looking at, and we'd really like to be able to come to a somewhat common, ID look and feel for the LEDs. I mean, at least we got the frequencies all aligned, but the placements are all over the place. So that's an area that's up for debate. So let's go to the one that everybody seems to be really excited about. This is the potential implementations. Now, these are all implementations with cases. So I started out with a 1U short narrow, and then a 1U short wide, then a 2U short narrow, 2U short wide, and then a 2U long narrow, 2U long wide. They're all pretty similar to what's defined in the SFF specifications, with a couple of exceptions. One, we're looking at growing the E3 short to 112.5 millimeters to try and bring it in line with the E1 short. We're looking at increasing the height of the E1 short cased version to 38.4 to bring it in line with the E1 long definition. And then the 2U wide, there's discussions going on between around having that at 15 instead of 16.8. That's an ongoing discussion. We haven't bottomed out on that one yet. So the powers, I think, are pretty much in line with what are in the specs today. Now, I put in a target NAND placement. Now, these are only for the narrow devices. I wasn't looking at, what would be involved in a dual PCB wide device. I decided to stay away from that. But the idea is, if you take a narrow device, in a 1U narrow, we believe we can hit somewhere between 8 and 12 NAND placements. In a 2U narrow, it essentially doubles and goes to 16 to 24. And then a 2U long, we believe it doubles again. Well, it essentially doubles again, goes somewhere to between 32 and 40. And I know you can debate those numbers to the nth degree depending on NAND package size and a whole bunch of other things, but essentially what I wanted to show with that was the story is we would like to be able to double capacity as you go up the food chain. So the smaller devices have X, the next step up is 2X, and then the next step up is 4X. So.
And I'll comment one other thing on the power. So at Microsoft, our simulations, at least for the 1U short wide, we think we can actually go a little above 25. So I think these are the details we want to work through to see if that makes sense in everybody's system. But 25 seems like a pretty conservative number.
Yeah, most of these are pretty conservative. We included a thermal study from Dell in this presentation, and it does show that these are fairly conservative numbers.
Yeah, and I think the way that we've done these in the past, really in the specs, right, is it's just kind of showing an implementation, and much like this slide is really trying to differentiate here between this is a absolute max, right? I think when we have our thermal methodology defined, you'll be able to see that, you know, if somebody wants to go do something really exotic, right? I mean, the connector supports power up to 70, 75 watts. And so it's really more of a question of, you know, do you dunk this thing in oil if you want to go do something really exotic? So there's not, one of the things that we saw is when we published the initial thermal simulation data, a lot of people took that as kind of gospel, that like that's what the form factor had to be. And I think we need to be careful to make sure that that's not how this is interpreted.
Yeah.
This is an implementation. And if you are a system designer and you do something really exotic with your cooling, you can do something different, you know, above or below that. So again, it's really just, we need to make sure everybody understands this is a implementation example, not gospel.
And there are also ways we can get around this. I mean, we could take this as this is the initial power state that it powers up in, and if your device can utilize more power, you can always go in and change the power state to set it to a higher power.
I think there needs to be some kind of methodology though behind the cooling. I mean, you can't just say
absolutely.
exotic. Like there's no
that I think the numbers that we list, right? No, and I think that's why we're coming up with a methodology, right? I mean, everything that's been published so far, there will be a methodology that will say when you do this, this is the thermal you can cool. If you know you do something else, you don't want the standard to restrict, you know, and say this is the only thing you can do. But I think it is good to have a standard methodology defined so that you can say, if you're using it in this manner and you're a system designer and this is how your thermal cooling capabilities are, then device vendors will go and make sure that it is, you know, will be able to be cooled in that environment. So no question, need to have a methodology there. But what I want to try and make sure is that it's not put into the spec that that is the only way that you can implement this form factor, because there may be somebody else that wants to implement a different methodology for something that's custom, and that's okay outside of, you know, it's kind of outside the scope of the form factor. Someone wants to use a different methodology for some unique use case, but the standard needs to have a methodology in there so that there can be a level playing field. Absolutely.
I think our goal is really to align the mechanical aspects and then have the power as a guidance, like this is what we think it could do, but then, as Paul mentioned, each system is going to have different implementations. I think the key is the mechanicals we can't change, the registrations, the datums, everything has to be the same.
Yeah, I guess that's a little bit what I'm speaking to, is this slide becomes a little, you know, power is kind of a wash in this slide because it's mainly discussing the mechanical implementation. And so it's kind of, I think there would be a lot of questions that would come up when you started talking about power without the airflow assignments and understanding the boundary conditions of the analysis. That's kind of what I was speaking to.
So I was going to, just to expand on what Paul was saying, I was going to point people to what HPE drove with the PCI SIG around characterizing PCIe cards and defining a fixture to get empirical measurements, as well as standardizing around the CFD guidance, much to what Jason presented in the last session. So our intent would be to create a thermal reporting spec, much like we did for PCIe cards, for at least for the E3 devices that have such a range of power implementations, to basically provide that guidance for the industry and standardize how it's reported back into the host.
I think that'd be excellent. I think that's something that the OCP NIC subgroup also did. They worked on doing fixtures and methodology, and I think that's the intent of what we're trying to do here. If we can get the methodology out there, if we have a volunteer to help design a fixture that multiple companies can use, I think that'd be incredibly helpful. All right, should we go to
think we should at some point try to come to an agreement of what the bounds of that fixture is based on a constraint of the device that requires the most cooling? Right. I mean, we should try to figure out how to define that fixture.
So maybe a proposal, if we can, so perhaps if we can figure out the thickness, so we're still, debating the 15 versus 16.8. I think once we establish that, perhaps the next step is to focus on how do we build a fixture, how do we characterize that, and if we build, 10 fixtures that go to 10 companies so everyone has the same fixture, we can all simulate it with our own devices or our own CFD. We can find ways to at least use a common test fixture separate than simulation.
So, Bill, it looks like this is good work, at least mechanically. It looks like you've considered a mixed drive scenario.
Yes.
Do you want to use this methodology of mixed drives to determine each form factor's cooling requirements? Is that what the goal is, or did you have purely mechanical intentions with these slides?
No, we want to determine what the thermal boundaries are. I don't want to. This is kind of a fine balance of, I don't want everybody to go wild, but I also don't want to limit a lot, some potential use cases. So this is a starting point. Now, like I said, we did a pretty extensive thermal analysis of at least the 2Us, and I included that in this presentation. So you feel free to go through that and look at it in gory detail and let us know if you have any questions.
Okay.
All right, should we go to Go ahead, Brandon.
I can take this offline is all I was going to say. I know we have to get through these slides, but I can send an email.
So in the end, will the SFF specs be updated?
That is a potential outcome of this, is we'd go back and revise the SFF specifications. I didn't put in a next steps. Haven't gotten that far.
Okay, I'm just wondering why this wasn't worked through the SFF committee. Seems like a great forum to do that. But
yeah, we've been revising the SFF specs all along.
Yeah, so I think the key intent, the reason we... Oh, go ahead.
Well, I just don't think that 6 months has gone by without us reopening one of those documents and changing it somehow.
Yep.
I think what's kind of different about what we're doing here is the reason we wanted to use OCP as kind of a sounding ground. We get many companies to come, voice an opinion, understand what we're thinking of, and get some of us, especially on the hyperscales, to actually partner with everyone else in the industry so that we're not forking off a bunch of different form factors, that if we can all try to agree on something common here, then we'll actually use the SFF standards body, and that is the correct place to do a standard. And so, yes, revising those standards or figuring out what makes sense, and certainly leave that up to all of you that are on those standards committees.
So Bill, one of my concerns on it, like basically on the topics under discussion, like the LED placement. So I mean that revising the spec now, I've already got, or I shouldn't say I have, but I'm aware of drives being produced with at E1.S with the current LED placement. So are we talking
But
then
Anthony,
revising the E1.S spec to
I
a whole
think,
new spec, or
but
go ahead, Mark?
there's nothing's going to prevent us from shipping whatever we defined 6 months ago, because it's a moving target, right?
No, I understand that. I'm
And
just trying to
and
say
the
that if
way
we
we,
revise the spec,
yeah,
are we
no,
going to be, is the old
you can't
drives
take,
that are existing shipping going to be out of spec?
no, you can't take that away. You wouldn't be backwards compatible.
Yeah, I agree. I think the concern here is the E1 to S. I understand the E3 is not there yet, but the E1 to S is in production now, and it's been an industry standard that's set, and people are designing to it. So the change LED placement or the current card design point is unacceptable that way. I mean, I think
the way we've been doing this, guys, in SFF, because a lot of you are on the SFF call, is we add another set of drawings and we don't delete, right? So it's not moving the LED, it's having an alternate location for it.
Right. I mean, so for example, though, like with a 2.5-inch drive, we don't want to go and change where things are, the connectors placed, registered onto the back plane, things like that, right? So it's a similar kind of thing. It is very painful if we want. I think the whole industry, we want to have as few as possible, and we already have existing definitions for this. So I think I would say that the heat sink, adding a heat sink that makes sense for the thermal situation. For adding that heatsink option makes a lot of sense to be able to cool a specific environment with a certain number of drives in a certain space. But changing the definition of what's already, changing what the definition of it, but slightly, but have this very, very similar device, that causes industry confusion and problem, right? Unless there's a specific reason that there's a problem, then after everybody's designing towards something for a year and a half, 2 years, then it's disruptive.
Yeah, but
I fully agree
also,
with Jonathan and Anthony. But so I think we should all set as the E1S. I don't think we should be moving the LEDs because you're right, products are in flight in there. So my hope, and I'm not going to speak for Bill or Paul, hopefully it's moving the E3 to match the E1.
well, how about moving the E1 to match the E1? Because your E3S is completely different than the E3L.
So you mean
those are the ones I'm
you
trying to
you
bring
mean
into
E1,
alignment.
Bill, you mean E1S
Yeah.
and E1L?
Yeah, I'm sorry, E1S.
And there's already
and E1.
been another movement on the LEDs, right? I think for E1L, but
yeah,
I mean, I think that all of these things we understand. Change is difficult, and so I think what we're trying to do is to come up to a, what makes sense. We're putting this proposal out, so we get that that's going to be challenging if we have to, change LEDs. But if we're trying to get to something that's a little bit more unified, again, if it's something that we say, we can light pipe that into a E3 case, and that way the LEDs, we can still reuse E1S PCBs, and maybe we can light pipe those. I think that's something that's mentioned on the slide up into the E3 LED location, but there's a lot of that devil in the details. It still has to be worked out. How tight the LED pipes, light pipes would have to be to do that. Does it make sense to try and align E1L, E1S, and E3 SNL for all LED, kind of a similar look and feel ID? That may have been something that we just couldn't get to on the first go around with EDSFF, and so it's really this is kind of just bringing it back up again to say, maybe this is worthwhile to take a look at that again and see what we can do to get a common look and feel across the entire family of EDSFF again.
So, Jonathan, to be clear, I have no problem changing the E3 LEDs around, but the fact that the E1s don't match each other is just kind of silly.
Yeah, are you saying the E3, the E1L and the E1.S you're talking about, right?
Yeah.
We have the LED. Yeah, the LEDs are different between the E1.S versus the E1.L and E3, and there's pros and cons to both. I mean, if we want to rehash that debate in here, or rehash that debate, I'm all for it. But I mean,
Yeah, I'll share an example of why that's important. So for Microsoft, we already use E1L. We've tooled up latches. We're going to use E1F. If we have to build brand new latches and different light pipes, that starts to reduce the reuse. That's why the proposal here is let's make the cased versions same size. And so I haven't actually looked at how the LEDs line up. If they're off, then that's kind of a challenge for us. That's yet another new part.
Yeah, I think that's where the mechanicals, for example, if you're adapting the E1 to S into an E1 to L, then you have light pipe that can go in and do that, right? So adjusting it to be the same in the same slots. You're not going to put like that's one fallacy is trying to make the alignment between. We had this rehashed discussion many times, and one of the fallacies that I think a lot of us have figured out was the E1.S going into the E1.L. Okay, there's a lot of adaptation you can do because that's there's more room to do that, right? So you can definitely have the same look and feel, plug that in the same E1.L slot. So if you want half a card or a smaller card to plug in the same slot, you can do that and have it almost pretty much exactly the same look and feel as the long today. But then you're not going to stick a E1.L in an E1.S slot. It'll stick out, out of the slot.
Yeah.
You know what I'm saying? So that's the benefit is there's really actually a lot of ways to adapt already the E1 to S into E1 to L slots. And the E1 to Ls, you don't want to plug those into E1 to S slots already anyway.
Right.
No,
but
the goal is to
also,
go with the smaller device in the biggest slot. Come on.
Yeah.
Doesn't make sense to go the other way.
And there's a benefit to just having a row of racks that all have EDSFF, drives in them to look the same, right? So even if we're not talking about swapping devices in and out, if you're just looking at your rack and you've got, a 2U box that's got E3s, a 1U box that's got E1Ss, a 1U box that's got E1Ls, and they all look different, the LEDs don't even register the same way. Clearly we have the same colors and we got that part standardized, that's good. But the ID look and feel part, that's why we're bringing this back up again, right? Because when you're in a data center and you've got all these devices, it would be nice if there was a little more commonality between them. That's what we're trying to get to.
Yeah, we had that come up in a customer survey of, what if I have, a rack and I have like a bunch of 1U servers and then a bunch of 1U JBOFs, and the servers have E1Ss in them and the JBOFs have E1Ls, and they look totally different.
Yeah, I think we have talked a lot about that, especially the main functional concern versus just a cosmetic is really for usage of like color blindness and things like that. And so sort of like stoplights, you don't want to like reverse the lights, right? So you want to make sure the red's on top and the green's in the bottom. So the green and the amber are in very specific places on the E1 to S. On the E1 to L, it's in specific places also, but just a different orientation, right? So it wouldn't be a differentiation that way that there would be a problem. It would be nice to have them the same, just from a cosmetic standpoint, and it's just maybe easier to recognize. But you would have that between all the E1 to L slots, right? It's really a question of where systems using E1 to S's. Do you have a lot of systems that are using E1 to S's right next to E1 to L's, next to U.2s or any other kind of drive? There's going to be different type of devices out there.
Is there any purpose to identify the difference between E1L and E1S if we're going to the same height? Would we want a labeling standard, or is that not in the protocol?
I would argue that's up to the carrier that someone attaches to it. So at Microsoft, we have proposals on how we're going to handle that.
Yeah, and HP typically handles that with the carrier. There's identification stickers on carriers that identify the drive.
Understood.
So I think we got really wrapped up around the axles on the LED, but I'm kind of surprised we haven't had too much pushback on making the E1S case the E1L height. So that's actually a good thing if we're not seeing too much pushback there.
I'm sorry we didn't talk enough about it. I'm really concerned about 38.4. I'm really surprised. Part of the idea behind the E1S is being able to have that common building block everywhere. And across multi-node systems, across different types of systems, edge systems, all the different types of systems, high-end systems inclusive also. For the common building block, that's why it's one of the main reasons it's shorter. Now, the 31.5 was a little bit shorter than the required for maybe the full 33, I think 33.75 or something like that for the case that we have now. But the E1.S cases now maxes out maybe around 34 millimeters. And that's like a common height for anything vertical in a 1U. So it can be used everywhere versus a 38.4. You really do have to have a specially designed, it's hard to fit in a 1U case without a specially designed bay. You can't use it for multi-purposed bays very easily at all. And it doesn't fit in some systems.
Yeah, and I think what you're getting at is you put an insert inside of a 1U platform, you're right, you do lose height. At least in the Microsoft design, you can see that we've open sourced through Open Compute. We fit the E1Ls in there, and that's the 38.4. But it is the chassis designed natively for that.
Right, and that's storage. Like for the JBOF for the Olympus is the it's the full height of that 1U can be used for the height of the drive. Versus it depends on the system. There's many systems actually, blade servers, or for multi-node, like a 2U 4-node server. Also some high performance computing systems. You have less than the height of like the 1U box. There's like the 1U rack space, the 44.45, and then there has to be a little bit of air gap, and then you have the outer shell. So if you just took that absolute maximum space you could get inside that, in a decently amount, it's not too thin of a metal, but a decent amount of metal, then that's where you get the 38.4. It's just really purposely designed for that. But to fit in across all the other kind of design points, then it doesn't fit for 38.4. At least not in all. We've done a lot of surveys across, pretty much the whole portfolio of our systems, across a lot of other industry systems. Because we were trying to see what we'd use as a common building block everywhere. So I think that's sort of the difference, is universality of where we can plug it in if it's 38.4. I mean, it could be a special heat sink or mechanical design just for one purpose of here's a larger size system, but I don't think you're really gaining a lot. I think it's more the the heat sinking surface area is really the width is the most benefit there.
Yeah, so Jonathan, were you guys thinking of using the actual cased versions? I thought like in all of those different universal environments, you were looking at using the PCB version to have the additional dimensional kind of flexibility.
Yeah, well, so there's different types of use cases and systems. I think the spacing is really the critical one of the questions. So if it's really tight spacing, then it's a lower power device. And the original intent was tight spacing. The first design point and target was tight spacing, and you get a lot of airflow between if you don't put a mechanical around it, and you pull up to a pretty high power without having to have any kind of mechanical metal box around it. But I mean, I think the logistics of supply chain, it may be useful to leverage the same components. So I think it'd be really nice for suppliers if there was some kind of commonality. I don't know that the 15 or 16 millimeters will be the best choice. Certainly not the best choice for all systems, but there's some places where I think we could all use the same common mechanicals, and that would be beneficial for everybody.
Hey, Bill and Paul and Jason, as far as the mounting holes are concerned, are those the mounting holes for the cases themselves, or are those the mounting holes for like the latch or anything like that?
That's the mounting holes of the cases. If you want to take like an E1 and put it in a carrier that allows it to go into an E3 slot.
Okay. Okay, because looking at the measurements or the table on slide 8, is that assuming that, I mean, that's assuming without latch or without any sort of retention
You're right. Yeah.
on the
Yep.
front.
Correct. That's PCB alone.
So is that assuming the E3 style of retention where you're screwing into the back, into the enclosure itself, or?
Yeah.
Yeah. Yep.
Well, hold on. So
Okay.
maybe I'm not quite following that. So that's not what my intent was here. My intent was forcing that 112 to be the depth, but E1S and E1L already have the metal flange that sticks out further.
Yeah, this is the depth without the flange.
Correct. But so maybe I'm not following. For the E3, how do you mount that drive? I've not seen the mounting
There's
proposals
basically
for that.
it's like a standard 2.5-inch drive carrier, very similar.
Yeah,
It either wraps around the sides or you can mount it directly to the front by screwing in. And so it's essentially that same flange that's on the E1 cases. It would be about the same dimensional size for a carrier that gets mounted either to the front or around the side rails of the E3.
Okay, so maybe I don't fully understand how that would be common between the E1 and the E3 then. Because in the E1, it's part of the case definition, and it's
Right.
common between all the widths, well, at least the case widths.
Yeah, and I think the only thing we need to do with E1 is allow us to have some sort of mounting scheme that allows us to put it into a larger carrier.
So I
Yeah, we
think
have
it
to
already
mount.
does that, right? With the screw holes in
Yeah,
the
and
front?
we're not necessarily saying that there's a to do there. I think it's just highlighting an action item. We need to go validate that
And
as
look,
we look at all the dimensional constraints, that everything works the way we think we do. But I don't think that. I think when we looked at it really briefly, we said we think that we can do that today, given the flange, and we use that flange to mount it into a larger carrier.
Okay. And I think that is the one thing that I would like to actually see us change with E1S, though. Between E1S and E1L, that flange, the screw holes, I believe, are in different positions. Right, Anthony?
Yep.
Yeah. Yeah, I mean, that's that's kind of where I was going with that is that the length with flange, without flange, you know. I mean, because we don't specify the length if you were to attach a latch to it, but what is the total length of the driving case? So.
I think the drawings I had showed, I think in previous ones, had shown the flange separate from this 112.
Yeah, that probably would be good to, we can, I don't know if the 2 slides down, Bill, does that have it in there, or do we have it in the backup?
No, I don't have that in there.
Okay. But yeah, that's clearly, I mean, we need to, that's the next step kind of level of showing the kind of the typical drawing dimensions that we had in the spec that we would show, okay, here's the next step of level of detail.
And I certainly would love to see the E1S and the E1L have the exact same mounting mechanisms. And then sounds like E3, you guys are open to doing something like that flanged approach as well. So if it was a similar flange, you'd be able to mount into that. All right, we're running up at 4 o'clock. I know we have the Cloud SSD spec coming up right now. So I guess we'll open it briefly for any more last minute questions, but we also have a meeting at the same time next week. So would someone volunteer, maybe Anthony, since you've been spending a lot of time with E1S, can you come in with a proposal for E1S and E1L, just where the mounting brackets are, with this proposal, any concerns?
You mean as far as the flange or with the general mounting holes, or what?
The flange, the mounting holes, and maybe, I don't know if you've already worked with Paul and Bill on what an E3 concept might look like, but as long as we have a common view, you can sort of overlay an E3 on there.
No,
see if that matches.
So this is the first I've seen this, so I can talk with Paul and Bill offline.
Surprise.
Come on, Anthony.
No, this is meant to be a conversation.
Sorry, were you?
Did I miss like half the meeting or something?
Yes, there are 2 meetings back to back. The first one was SSD form factor, which you're catching up on the tail end, and we're about to switch to the cloud SSD.
That's just great. So somehow I missed the. Okay.
Happy Thursday, Dave.
Yeah.
Yeah.
Good afternoon.
All right, any last minute questions on this topic before we change gears?
Nope.
All right, no last minute questions. So we do have the mailing list, so a lot of these questions you can blast out to the OCP mailing list, and we can continue that method until we hit next Thursday.
So is this
All right.
particular version of the slides posted somewhere, or did you send these out? Sorry, these look different slightly from what you sent out before.
This is not what we've sent out yet. So the ones that I sent out a couple weeks back, that was a Microsoft perspective, what we think. This was something that originally started with Bill and Paul, and then I joined in on this. So we're trying to show this as kind of a joint slide deck. We'll send this out afterwards to the mailing list.
Sure, thank you. That would be great. Thank you.
Perfect. All right, and do we have Ross and Leon, the Cloud SSD spec? Do.
All right, guys, I'm dropping off. Thank you.
Thanks, guys.
See you, Jason.
All right, Ross or Lee, who is going to be driving the presentation?
Huh. So we hadn't done rock paper scissors on that. So
no, I'm on now.
Hey, so Ross, you want to drive for now, or
I can either present or take notes. Take your pick.
Go for it. Go for presenting. I'll take some notes.
Okay.
Whoever's typing should probably go on mute.
That is some very loud note taking.
That's not me. I haven't started yet.
Okay.
Okay, give me a minute to figure out how to do this on here.
I think you're connected on web. I think the only way in web is maybe to share a screen. I don't know if the web interface lets you do an application.
It does not, at least not for me. Okay, am I presenting now?
Yes, we can see your screen.
Great. So, hopefully everybody saw how we sent this across the reflector the other day. And maybe I should just scroll to the table of contents and ask if there are questions in this, because I don't think we want this to just read through this. So as you can see, there are MV express requirements, PCIe requirements, reliability, endurance, thermal, form factor, S and bus, security, labeling, compliance, shock and vibe. I'm not quite sure the best way to do this. Should we open it up to
So Ross?
Yeah.
Can you go slowly through the E1S sections?
Sure, we can do that. For you, we can do anything.
Thanks.
Let me scroll down to form factor. Do you want me to start here with general requirements, or you want me to keep going to E1S?
Yeah, this is great. Thanks.
Are there, if I start here, I'll wait to see if there is a question, otherwise I'll keep going.
Okay, keep going.
And then there's a power consumption methodology.
By the way, for hot swap, we mean what PCI now calls the managed, as opposed to surprise, or do you mean surprise removal?
Surprise insertion and surprise removal.
Okay. So in the near future, I may provide a bunch of inputs to more clearly specify things like that.
Okay. And we have power consumption methodology, and I'll keep going. There are, power levels using set features. Then I'll skip over M.2 and we'll go to E1S. And I will stop and camp out here.
Yeah, Mark, is a concern around what we just heard about whether or not this OCP spec will be updated to reflect if there are, for instance, any changes to the E1.S spec that comes out of SFF and OCP in the next, say, 3 months.
Yeah, this is meant to be a living document, so if that as we adopt things, yes, we would modify these sections. Thoughts? Mark, did you have other inputs? Or?
So I had a question, Lee. The last one there, the panel indicator specification in OCP, I'm not familiar with that, but does that contradict the LED specifications in EDSFF?
No.
Or do we know if it aligns?
So EDSF says it's amber. This specification gives a clear definition of the definition of amber.
I think that's in 1009, I think, right? We have wavelengths and other things that define that.
Yeah, you do define the green and amber wavelengths in 1009.
I just want to make sure that there's not a conflict there.
That's a fair question. We can check and make sure there's no conflict.
Okay.
There was an issue before, but Anthony fixed it, my understanding.
The intent was not to generate a conflict.
No.
Any other comments about this?
No, thanks. That's what I wanted to focus in on.
I don't know.
I've got a totally unrelated comment, not about E1S, but I perused it quickly, so I may have totally missed it. But I think I did not see a namespace requirement. Is that correct?
Oh, that's up in
number of namespaces.
So yeah, Ross, you want to go back up to that? We do require base management and support and namespace attach.
Right.
Yeah.
I saw that.
You know where that is? I'd have to search. I can't. I'm sorry. I've gone through this so many times. I should know.
And I think I just didn't see anywhere where it specs out how many namespaces you guys want, but maybe I missed it.
Oh, that's a good question. I'm not sure we did.
No, I think it says a minimum of 1, but it doesn't say a max.
Or whether there's a configuration from the factory that we are specifying, I think that would just be.
Here it is. The device shall have 1 namespace as shipped from the factory.
Okay.
So you guys don't have any requirements for like 128 namespaces currently?
Well, at least not, shipped from the factory, we wanted to have 1. We want to have the ability to manage those namespaces to start to break the curve up if needed.
Yeah, I know for us, that's something that we've been looking at from a capability perspective, right? That's something that has to be forecasted really early because that drives ASIC requirements and other things. And so device suppliers we found have had a challenge to meet some of those requirements if they're not told ahead of time that even if it's shipped from the factory with 1, but if we really eventually want to use 128, that might be another. If you guys have a number in mind, that's one thing that we've been looking at is around that 128 number.
Okay, good to know. I guess that's then some input from the drive guys to see if that's that's easily, that's really hard.
Yeah, I think some can achieve it, and others are, maybe in their next gen is what we've been getting feedback on that so far. But
Got it. Okay. So let's see some thoughts here. So Ross, maybe wanted to let me think about this. Some highlights we might want to point out. Maybe if we want to go to the log pages.
Sure. I can go to C0. You're thinking C0 log pages or somewhere else?
C0 is good. So the idea is here we have a series of quote unquote vendor unique log pages. And obviously the impetus here is that all of the companies that kind of have requirement stocks to be able to look at a lot of these things, we're all looking for the same things. And the problem is up to date, we've all wanted them, basically the same values, but we want them in different places, which is silly. So the idea is here is, hey, if on these things, if we can come up with a good solid format for where these all should be in general, then that's what this is attributing. And then the thought would be, hey, if then this becomes a general thing for cloud or even beyond that, then this could be something that could be brought into NVMe and taken from the vendor unique space and put in the standard NVMe space. So I want to ensure here that our feeling is that, yeah, we've got all this stuff. Some of it's kind of esoteric and some of it's not. And I have no problem with any of migrating into, say, 2.0 or something around that in the NVMe itself. So this is not meant to usurp NVMe in any way, shape, or form. This is kind of inform things as we work through how this kind of looks in the cloud case, and then we can certainly move this into NVMe if so desired.
This is just stuff we need that's not in NVMe today.
okay, so all of these are, because I hadn't done the compare yet, and I was curious. So just all of these are things that are not in the device statistics.
Yeah, there's a couple of things that they're repeats, but that's so for ease of access, and it's called out.
Oh, okay, got it.
So you have everything from media units of read and written in bytes, bad user NAND block counts, system area NAND block counts, XOR recovery, uncorrectable read errors, soft ECC error counts, end-to-end correction counters, system data, how much refresh counts, user data erase counts, thermal throttling counts, PCIe error correctable counts, and complete shutdown, percent of free blocks, capacitor health. This is basically a gas gauge from where were you at factory exit to where am I going to be in trouble that your capacitance has fallen too low. Unaligned I/O, security. Let's see here. We have
how do you guys want to handle feedback? Do we want to kind of do feedback live in the meeting here, or are you looking for for everybody to submit, hey, did you guys think about this or that, or what about that,
Yes and yes.
Okay.
Either is okay. I mean, the point of this is at least now you know where we're at.
Yeah. No, this is good. I was looking at it, and it's got a lot of good overlap from a lot of our enterprise specs, and so the ability to get even closer and closer, if it's possible, between cloud and enterprise and have one firmware spec that we could have drive suppliers go towards would really be great from a volume perspective for driving volume. So I was really pleased to see this because there was a lot of commonality between our specs.
Yeah, and so the idea to be able to drive that to the point where there's enough volume to create this as firmware for everybody. Right.
Yeah, Ross, Lee, I think I've given you guys this feedback offline, but is there some way to potentially align to the NVMe management interface? If there is some opportunity in the NVMe MI 1.2 specification to, have a subset of, or make the minimum requirements more lax, so that whatever the SMBus stuff that you need that is probably the NVMe MI today is overkill for, can be maybe a subset. Because what would be really nice is if a vendor implements NVMe MI for an enterprise customer, that the cloud would be just a subset of that or a smaller portion of that, and kind of get it for free rather than doing a secondary SMBus implementation.
Yeah, certainly open to some of that. Obviously there's, my last guys are rolling seats chairs right now. But yeah, we can certainly chat about that.
I mean, yeah, there's no problem with chatting about it. It's just, as you know, that's a challenge of migrating, and what do we get for it?
Yeah, and I think potentially there's some, the OCP security work group is working on some things, that over SMBus for like device attestation and things that SSDs may want to, use MCDP over PCIe and other, stuff that's kind of already set up on NVMe MI that we might be able to tie all together, but maybe it's for a Rev 2 spec or something, but. Yeah,
So,
nice to have.
So can you unpack a little bit what's happening in the security one? I was not aware of this.
Well, I will, send an email. I don't know how much of what I was told because I didn't attend the security meetings, but I am talking to our Intel rep that attends the OCP security worker meetings, and I believe he's working with a lot of the guys at these that are from your company as well.
Okay. So just if Brian Kelly's a part of it, then that's all great. And then
okay.
But
cool. Yeah, I mean it does tie into Cerberus and the other platform level security stuff. So.
Cool. Yeah. All right.
Okay.
So on Smart, on the security version,
yeah,
I didn't quite understand what that was a version of.
Oh, at the bottom. Wait.
Where there's a
right
point
there.
where, yeah.
Smart 22, you're asking about, I assume, right here.
Yep. So is that a different than the other IDs we have now, and how do we distinguish what this talks about?
So this basically is a number of times that we have had to put a firmware in there that doesn't allow rollback because of a security issue. That make sense? So a lot of times we'll put in firmware, and you do firmware and firmware, you can roll forward and you can roll back. But as soon as you put one that you really want to block off a security issue, you have to block rollback, and we want to see how often that's happening.
Okay. Yeah, we may need some rewriting to make that clear, because I thought it was a version number, and I was trying to figure that out.
Fair enough.
Yeah, I'll come up with some words. I'm happy to.
You come up with some favorite words, you can send them to us.
Right.
So you're saying that's just more of a counter?
Yeah.
Exactly.
Yeah. And is that for any rollback, or it really is meant to only get security rollback prevention?
So I think we actually talk about that in the sense of we would want the firmware not to allow for rollback in any case but in a security case.
Sorry, you kind of trailed off at the end there, Lee. What?
Oh, sorry. Where I'm pointing my voice here. So I think the thought was it would be, hey, pretty much you can roll back from any firmware, but if there was a security issue, you would block it. And so this would certainly be a thing. Now, if there are cases where we're feeling that we can't roll back even though it wasn't a security issue, then we certainly want to talk about that and whether that needs
Yeah, right. So that's what we've seen. We've got cases where we have, no rollback due to security, and then sometimes it's such a huge bug, we've got no rollback just because it was a huge bug.
Got it. Okay, fair point.
Yeah. Okay.
Ross, the other one we want to kind of delve into real quick is the thermal throttling and the composite temperature.
Sure. Let me go up to the top and find where that is. Okay, you want to start here or me to go down the throttling?
Just, I think the curve is probably there are
okay.
questions about that one usually. So
here we go.
So this one's kind of an interesting one. Hopefully, I mean, we had discussions with several folks on this, and I want to make sure that this is kind of clear. Since this is a composite temperature, it's already a lie. So we want everybody to lie the same, so that I can, or Ross can ensure that our fan controllers understand what the proper lie is and do the right thing in all cases. And so this is where we're saying that basically, when the device is kind of running along and we can be hammering it pretty good, but it's getting a good airflow across it and it's just kind of running normal, then we want that to kind of report it as 70 degrees C. But as soon as the device is starting to feel, ooh, it's getting warm in here, we want that temperature to start to ramp up from 70. And basically 77, you'll report that 77, and that's the point where you're going to basically send us an AEN saying, I've got a critical temperature here, and I'm going to start thermally throttling.
So if you're not reporting 77, you should not thermal throttle.
And sorry if I missed it, if it's in here. Do you have a case temp, or is that 70 C as well?
No, it's the case temp is pretty much irrelevant. It's
okay, so you're just
underlying your composite temperature reporting.
Got it.
You're saying, hey, everything's good, and whoa, starting to get hot. Oh, now I'm really, really hot. I got to do something about it.
Yeah, I think the questions around, and we're having conversation with customers about raising the SSD case temp from 70C to 80C in many scenarios where the drive's being hot plugged, where a technician can properly remove the drive. That helps the drive, not thermal throttle as soon for higher performance, higher power stuff.
Yeah, and we think of that as completely independent from this reporting.
Nice.
Because, as I say, the composite temperature is already not really, it's a lie already because it's made up of a bunch of stuff from behind the scenes.
And if this is an M.2, for example, you don't have a case temp, basically.
Yes.
Well, for a touch temp, you do. I mean, it's
that's true.
Anywhere you can touch, it's just the UL spec. I mean, I think we're all aware of that. And I guess it would just be, do you have a UL requirement in here? I mean, must this device meet UL spec? I'd
yes.
imagine yes is the answer, right?
What else?
Where else would you like me to go now, Lee?
That's what I was trying to think, if there's any more, anything deep in here. I think most of this is kind of common sense and hopefully apple pie.
Is there anything else anybody wanted to bring up? Otherwise, you can just send us if you have any feedback.
I had a question on Therm 2. It's right above this.
Okay.
The specs mainly targeted at drive vendors, but it says a thermal study of each platform is required. And then it goes on to say the thermal design shall be validated. Are you expecting the drive vendors to run the simulation on your thermal platform, or you're asking for the drive vendors to provide a thermal model?
So for Facebook, we want a thermal model, flow therm or something like that, and then we will go study it.
I guess I would suggest that this requirement be reworded to a request for a model to be provided for the system vendor to do the platform study.
Mm-hmm. We can look at this. Other questions? Hey, did you want to go anywhere else, or should we?
Yeah, I was just gonna do a quick scan through the table of contents here to see some fun stuff that we hadn't really touched on. Maybe get down to the appendices. Appendices.
Here?
Yeah. So we tried really, really hard to align everything. Didn't quite get to 100%. So we have some things that are different. We tried to, like a lot of it would be around basically, hey, we want the ability to configure this way or that way, and then in certain cases, Facebook will say, I want it configured this way, and then we'll have to say, well, unfortunately, we need to have it configured that way. So as you can see, here's a few of the things where, given the idea of being able to do one way or the other, here's the way Facebook wants it configured. And you probably would see down below in mine, Appendix B, I'll want it the other way or in a different way. There's also some things around the performance requirements. I still have some hopes that we can align on that better over time here, but currently some of the performance stuff is separate. So
metrics it's intended for these configuration things. The hope is that for drive vendors, these are flags, and so they can just configure them as opposed to major changes.
Yeah, exactly. And with that, that's about all I can think of right now. Anybody else have any other thoughts?
Great job, guys.
Thank you.
So I think if you send us any feedback you have, and then we can update this and get it finished off. So I appreciate everybody's time in looking this over and their thoughts on the topic.
And with that, back to you, Jason.
All right, thanks, Ross. Thanks, Lee. Anyone else have any other questions, or should we give everyone back 30 minutes? Going once, going twice. All right, everyone have a great week. Thank you so much, and hope to see many of you next week at our SSD Form Factor version 2. Thanks, guys.
Bye, all.
Bye.
Bye.
Thank you.
Bye. Thank you.
Bye. Thank you.